Hello, this is Ms. DB, and in this lesson we're going to go over Chapter 5, Section 7 on the Pythagorean Theorem. We're going to start with a quick warm-up. You should know how to do number 1 and 2 easily. If we are going to classify by its angle measurements, our choices are acute, right, or obtuse. So number 1, every angle is less than 90, so that's acute. In number 2, I won't show the... There we go. And number 2 has one right angle, so that is a right triangle. Now in number 3, we're going to take 2 times the square root of 3 times 2 times the square root of 3. You put the whole number parts together in the front, and you would get 4. And then you take the square root of 3 times the square root of 3, which is the same as 3. And 4 times 3 is 12. So the square root of 3 times the square root of 3 is 3. Or the square root of 9, which is 3. Now in number 4 it says if a equals 6, b equals 7, and c equals 12, find a squared plus b squared, and also find c squared. So if we take a squared, we'd get 6 squared. If we take b squared, we'd get 7 squared. So we'd have 36 plus 49. 36 plus 49 is 85. And if we take c squared, that's 12 squared, that's 144. And it says which value is greater. So the c squared one would be greater. So you'd put a sign like this where this is less than, because 36 plus 49 is less than 144. Alright, use the Pythagorean theorem and its converse to solve problems. That's what we're going to do today. And also use Pythagorean inequalities to figure out if we have an acute, obtuse, or a right triangle. It's like a variation of the Pythagorean theorem, which you probably remember from years past. And Pythagorean triple is our only vocab word for today. Alright, the Pythagorean theorem is probably the most famous mathematical relationship. We've learned this even in this book in Chapter 1, Section 6, when it basically says that the sum of the squares of the lengths of the legs of a right triangle equals the square of the lengths of the hypotenuse. You have to have a right triangle to use the Pythagorean theorem. And we usually say it as a squared plus b squared equals c squared. In this problem, we are going to find the value of x. This is kind of the most basic type of problem for the Pythagorean theorem. So we know the Pythagorean theorem is a squared plus b squared equals c squared. We replace a for 2, 2 for a, 6 for b, and then we're going to find what is the other unknown side. Now if you're looking for the hypotenuse, the variable goes all by itself over here. That's because we're looking for the hypotenuse. The hypotenuse is always opposite the right angle. So in this one we were going to take 4 plus 36, which is 40, equals x squared. We don't want x though. We want x, not x squared, so we still have to take the square root of both sides. Now, you can take the square root on your calculator and get a decimal number, but the better way is to simplify your square root. To simplify square root, you rewrite 40 as what times what equals 40. So in this case, 4 times 10 equals 40. Now, there's different factors of 40. I could have used 2 times 20 or 8 times 5. The reason that we pick 4 times 10 is because the number 4 is a perfect square. I can take the square root of 4. The square root of 4 is 2. So I could even rewrite this as the square root of 4 times the square root of 10. But the square root of 4 is just simplified as 2. So I'd really just have 2 square root of 10 then. That's simplifying a radical. Okay, this one says find the value of x, give your answer in simplest radical form. But this time, x is used in both the hypotenuse and in one of the legs. So this is a little bit more of an algebra problem. We're still going to use the Pythagorean theorem. And now we're going to substitute for a, x minus 2. So this is a little trickier. When you have x minus 2 squared, that's the same as x minus 2 times x minus 2, and you have to FOIL that answer. So x times x is x squared minus 2x and then another minus 2x is minus 4x, and then negative 2 times negative 2 is plus 4. So first, outer, inner, last. Then we have plus 4 squared, which was 16. Now we can combine our like terms, and we do that by putting the 4 plus 16 together. We subtract x squared from both sides so that we can get those together, and x squared minus x squared is 0. You don't have to write 0x squared. It's not 1x squared. It's gone. The x squared term canceled. It's gone. And we're just left with this. So now we can solve for x by either subtract 20 from both sides and divide by negative 4, or this solution is to add 4x to both sides and then divide by positive 4. You'd get the same answer. Either way, you're going to get that x is equal to 5. So this one uses a few algebra skills, and hopefully you can correctly solve that for x. In this example, it's an application problem. They have a rectangle, and they want the diagonal to be a 12. Do they have a picture here of it? Let's draw a picture. So they've got a rectangle, and they know that the diagonal needs to be 12. And it's a rectangle, so it has a right angle here, so we have a right triangle. We also know that they want it to be a ratio. The length should be in a ratio of 3 to 1. So if I call this 3x, I could call this 1x. So the way they say it is, let's go ahead and use, they use w instead of x, but same idea. So they're going to take 3w squared for a squared plus w squared for b squared, and we know it's going to be equal to 12 squared. So we have, first of all, the 3w squared, you have to square the 3 and the w. So you'd have 9w squared plus 1w squared is equal to 144. So that's where they got the 10w squared from. Now we'll divide both sides by 10 and get w squared equals 144 over 10. Now we have to take the square root of both sides. And when we do that, you could do it the way they did. They just got a decimal approximation. You could also do it like this. Oh, this stupid pen. You could also do it like this. The square root would be equal to the square root of 144 over the square root of 10. And the square root of 144 is 12 over the square root of 10. But we can't leave a square root in the denominator, so then we multiply top and bottom by that square root to get w equals 12 square root of 10 divided by 10, because square root of 10 times square root of 10 is 10. That simplifies divide top and bottom by 2. You don't divide the number inside the square root, just these two numbers, the 12 and the 10. So 6 square root of 10 over 5. This would be the exact simplified form. This is the approximate decimal form. It really depends what you're asking for. If you're looking for the measurement of a frame, then it makes just as much sense, probably more sense, to have the decimal version than to have the exact radical simplified form. All right, if you have a number, a right triangle, and one side is 3 and one side is 4, 3 squared plus 4 squared is going to be equal to 25. The square root of 25 is 5. A 3, 4, 5 triangle. This is called a Pythagorean triple. There's some other ones. If you have a right triangle with legs of 5 and 12, the hypotenuse turns out to be 13. And there's one that's 8, 15, and 17, and 7, 24, and 25. And then there's multiples of those as well. Like you could take 3 times 2 and get 6, 4 times 2 is 8, 5 times 2 is 10. This is another Pythagorean triple. Or I could multiply each of these by 3 or 4 or so on. So they have to be whole numbers. They're never decimals. They're never fractions. And it has to be that the square of the two smaller ones, when you add the square of the two smaller ones together, you will get the square of the bigger one. So to check if you have a Pythagorean triple, you take the square of the small one, the square of the big one, and you see if it equals the square of the big one. Or you just see if you get a whole number. If you get a root or a decimal, then you don't. So in this one, they want you to find the missing side length, so you take 14 squared plus 48 squared, and you see what you get. Then when you take the square root of both sides, you get exactly 50. That's a Pythagorean triple because all three numbers are whole numbers, 14, 48, and 50. It's also a multiple of 1, I believe, that we did on the page before. Whoops. Yeah, see, it's if you multiply 7 times 2, you get 14. 24 times 2 is 48, and 25 times 2 is 50. The more of these you do, the more that you'll recognize from those on that table as either being those or multiples of those. They can make it easier to find a missing side of a triangle too. Now here's one that I really want to look at, because in this one, the side that we're missing is not the hypotenuse. Very common mistake that students make is they look at the two numbers and they write 4 squared plus 12 squared equals x squared. Not in this case, because the hypotenuse is 12. That's what it's going to be equal to. So it's 4 squared plus b squared equals 12 squared. You can use x again, but it's not the hypotenuse that's missing, it's one of the legs. So now what we do next is we write 16 plus b squared equals 144. Then the next step is to subtract 16 from both sides, so that we get b squared equals 128. Now we have to take the square root of both sides. The square root of 128 is 8 times the square root of 2, or approximately, whatever it is that you get. Let's see, like 15 or 16 or something. No, it can't be. 10, 11. 11 times 11 is 121. 12 times 12 is 144. So it's 11 point something. I'm not sure what. So is this a Pythagorean triple? No, because you did not get a whole number. 8 times the square root of 2, or 11 point something something something, is not a whole number, so this is not a Pythagorean triple, but you can find the side length. It doesn't mean there's no answer. Okay, the converse of the Pythagorean theorem gives you a way to tell if the triangle is a right triangle. So the converse says that if a squared plus b squared equals c squared, then you know you have a right triangle. And there's also two inequality theorems that come in very handy. If c is the longest length of a triangle, if c squared is greater than a squared plus b squared, then it's an obtuse triangle. If c squared is less than, then it's an acute triangle. Remember, if c squared is equal to, then it's a right triangle. So the converse of the Pythagorean theorem works if it's equal, and if it's not equal, then we can see if c squared is greater than the sum of the other two, then it's an obtuse. If c squared is less than the sum of the other two squares, then it's acute. So here's the three different things that can happen. Those are the three different ways that you can have a triangle. All right, so let's see. Let's tell if the measures of the side lengths. Tell first of all if it can even be a triangle. If so, classify the triangle as acute, obtuse, or right. So we learned in the last section, or the last couple sections, that in order to be a triangle, you would take the sum of each side, each of the two sides, and it has to be greater than the third. So 5 plus 7 has to be greater than 10. Is that true? Yeah, that'd be 12 is greater than 10. That checks. And then we have to add, we'll add 7 plus 10. That has to be greater than 5. Well, that's 17. That definitely works. And then we have to add 5 plus 10, and it has to be greater than 7. All three of those have to be true in order to meet the triangle inequality theorem and know that it can be a triangle. So this works. So the first part is yes, it's a triangle. The second part now is to tell what kind of triangle we have. So our side lengths again are 5, 7, and 10. That was our triangle, 5, 7, and 10. The longest of these is 10. So we put 10 for the longest side, and we don't know if it's going to be an equal sign, a less than, or a greater than. I'm just going to cover that up for now. And then we have 5 squared and 7 squared. So now we simplify, and we would get 100 here, and this would be 25, and this would be 49. So we want to see, is 100 equal to 25 plus 49? Is it less than or is it greater than? So what's 25 plus 49? It's 74. So 100 is greater than 74. So if c squared is greater than the sum of the other two, then it's an obtuse triangle. If this is greater than, it's obtuse. Make sure that c squared is over here on the left side when you compare this. All right, let's check. This is just another example, same thing. 5, 8, and 17. So the first thing to check is if we even can have a triangle, because sometimes you can't. So 5 plus 8 has to be greater than 17. But 5 plus 8 is only 13. 13 is not greater than 17. This cannot even be a triangle. So don't go through all the work of telling if it's acute, obtuse, or right if it can't be a triangle at all. Don't forget to do step 1. All right, you can do this with decimals or fractions as well. So first thing is to check if it can be a triangle. So I'm going to take 3.8 plus 4.1. That's greater than 5.2. So the first one checks. These plus this was greater than. If I add these two together, it's greater than 4.1. So that checks. And let's see, I have to add these two and see if it's greater than 3.8. It's going to work. So it can be a triangle. So I did step 1. Now we have to classify it. The sides were 3.1, 4.1, no, I'm sorry, 3.8, 4.1, and 5.2. You put the biggest one on the left side and square it. And then you take the square of the two smaller ones and add them together. Now you'll probably have to get a calculator out to find the squares. And you get 27.04, and you want to see is that equal, less than, or greater than these two numbers added together. So when you add these two numbers together, you're going to get something bigger than 30, like 31. And 27.04 is less than 31.25. So therefore, this is an acute triangle. Remember, if you got that one thing was equal to the other, then it would be a right triangle. Like if you had the numbers 3, 4, 5, 3 squared plus 4 squared, and 5 squared. So you put the bigger number over here, and you want to see is it equal to, less than, or greater than. And 5 squared is 25. This would be 9 plus 16. Well, in this case, they're equal, so this would be a right triangle. So if you get a problem like that. All right, so good luck. Let me know if you have any questions, and have a great day.